Good morning and welcome back to the Explicit Measures Podcast with Tommy, Seth, and Mike. Good morning, everyone.
Good morning and happy Tuesday, gentlemen.
It is a happy Tuesday.
It is.
Jumping back into things here, just for letting everyone know, this is a pre-recorded episode. So this will be a recorded episode for those of you who are joining live. Just FYI about that real quick. Our main topic for today will be talking about Fabric and focusing on kind of two area or aspects of Microsoft Fabric. The Lakehouse or data warehouse. Kind of thinking through where they are good for and potentially where should we be spending our time in building our analytical engine or analytical solutions nowadays. So that'll be our option there. And then before we get to that main topic there, let's do a couple news articles. So Tommy, over to you.
Yeah, so there's actually a new white paper in the works by Marco Russo and Alberto Ferrari, and it's on all about visual calculations. It's still very much in draft, but it's basically
the article or the
article
calculations.
Yeah, it looks the both. The
How
white
do you know
paper,
it's in draft? Did they say it's in draft?
Yeah, the first box says.
So this is a LinkedIn thing.
No,
this is their white paper you're talking about. You're saying this is a white paper. You didn't explain that very well.
I said
it's a white paper on top of. Okay, got it. I'm with you. Got it.
Is it a white paper that's in draft?
Maybe Mike needs to wake up a little more.
I think I need more coffee.
I think it was a white paper that Marco Russo wrote.
There we go.
Roberto Ferrari.
I thought you said new website. I heard you said white paper. I heard website. Oh boy, this is going to be an interesting episode already.
All right, let's start over. Tommy,
seriously.
What do you got
okay, so SQL BI, Marco Russo, Alberto Ferrari, ciao friends.
Ciao.
They have created a page that's a white paper that right now has the structure of what will be a very complete set of education and understanding about how visual calculations work. Right now, the content only has really the agenda and some introductions, but if you've noticed SQL BI's website, their blogs, there's been a lot about visual calculations. I think on what day was it? On March 16th, Marco Russo, visual shape, visual calculations. So they're doing a lot more articles. And I think they're going to put all this into the white paper. So this is pretty, I don't know, this is kind of significant. If Marco Russo and Alberto Ferrari are spending the time to do the white paper, they're obviously seeing the need probably with their community and who they're talking to. They still don't exist in the model. It is DAX, but we've had a lot of conversations about this. But I think this is a telltale sign to me, the fact that they're going ahead and putting a lot of time into visual calculations.
Well,
they've always been very proponent for this. Yeah, so that's what I was going to say. This is not a surprise to me. They've been super advocates for visual calculations for quite a while now.
I mean, what I would say is what's not a surprise is everything relating to a model or how something operates with DAX. They are all over all the time. So I'm super excited that they're getting engaged here because it is different, right? How visual calcs work within that framework, and having explanations, especially in the detail that they provide, is going to be extremely helpful for the community for sure.
Now, the interesting thing here as well with this article is you don't get this white paper. You can't go get it. You have to be a subscriber of their SQL BI Plus membership in order to get the white paper. So they're going to kind of talk you through the ideas here, but they're not releasing the white paper out to non-SQL BI Plus members, which is interesting as well. So even just walking through like the items they have listed in the outline, here's the following modules that are going to be handled inside the white paper, right? One of them is just what is a visual calculation? What are window functions? Understanding the visual shape, which is interesting. Creating new context columns or something like that. And I think this will be very useful. And if you think about what visual calculations can do, right? It's kind of an after effect of once you've already produced the aggregations across the entire model. It can simplify or reduce the load that you need to compute because it's now only computing inside the context of a visual. What do you guys think? Is visual calculations all hype or like a real thing?
Go ahead, Tommy.
At first I think I was a little conservative in terms of thinking what visual calculations are going to do. Because again, any calculation you create only lives really in that visual. It's not actually shown in the model. So we're talking about the lack of metrics. But I don't know if you remember a while ago about report level measures and like all the needs to create design based report measures. Whether it's to show trending and arrow, and there's a lot more use cases that I don't want to bloat up my model, especially if it's a simple just show me previous over previous or growth or comparison in that visual. Very much like Excel, that is never going to be, in a sense, maybe it's never part of a certified semantic model, but it's just a visual cue. Honestly, now that I'm looking more and more at this, I've seen a lot of people writing about this. I'm still wondering all the different use cases or when it makes sense to do it. Is that something we go to your priority list? Just like right now we go summary page, drill through. We always need a drill through page, or usually will visual calculations have that same precedence in my checklist?
I don't know. I mean, I think there's two areas that I think about when I think about visual calculations. One is the governance and control of it, just from a people can write whatever measure they need to. On the other hand, I think of it from a scalability and speed standpoint, right? So it doesn't make sense if you have fact tables that have billions of rows in them and you're summarizing things across those rows. It doesn't make sense for you to have to build complicated measures to get you, this period versus last period type calculations, or one row minus the second row, like, sorting and ordering things inside the visual. So I think from a performance standpoint, this makes a lot of sense. My hesitation is, how discoverable will these be, and are they going to potentially change the models that the central BI team produces and shift them away from something that is centrally modeled to what the user needs? And again, I feel like I think the use case is strong enough to say yes, this is valuable. Where I'm still hesitant right now is what's the best way to monitor and see what's going on in these visuals, and what is the performance impact on those to rendering the report for end users, right? So, if an end user comes into me and says, "Hey, my visual's slow," okay, great. I can run the query and see what it does. And if the engine is doing fast, what did they do in the visual calculation that made it slow? Something else here that I would like to kind of maybe explore a bit more too is, if you're in the context of a single visual, there may also be something here around, can I do SVG type things inside those in visual calculations as well? Add graphics or images or line charts or little bars that I need to inside the context of that cell in the visual. So that'd be another one to kind of also explore too. But again, you're now really, really stylizing one particular visual. And I think the extent here is you're not going to reuse that calculation across multiple visuals on the page.
Yeah, I mean the other. So I think a lot of our conversations are always kind of bent towards what is a business user building, because we're going to need to make sure that we can scale it up, and it's not a bad thing. It's constantly going to be the central BI, or the team's responsibility for performance, etc.
Sure.
But one of the things with visual calcs that I think is crazy, like amazing, is it unblocks some of those really big cliff DAX things for
Yes.
new users, where it's the running. It's a joke, right? But right after your normal summer average, somebody goes, "That's great. I'd love to see that over time," or "How can I compare that?" And then you're instantly into time calculations. So
Yeah.
the fact that the functions that they're supporting in a different way, right, in visual calcs, unblocks that and instantly brings, I think, a whole lot of power for end users to get a lot of value in the the insights of month over month or year over year or whatever that is, in comparing data sets that otherwise has been extremely difficult. And many don't power through the DAX that you're just automatically thrown in to be able to do that. And
Yep.
I think the value alone sits there. And while I agree, like certainly it remains to be seen how we figure out how to ingest or like just understand what's going on a report page, right? Right as a whole bunch of like community projects where we're like dialing in all the components of a Power BI report. Hey, it keeps us interested, right?
I feel like the only miss that I see right now here for visual calcs is the ability to add a library of visual calcs that you can pick from and use from your central BI team. I think to me that's the major missing part that I see here is there's going to be a lot of really creative features that people are going to build with visual calcs. People are going to want to extend it. It's not going to be just a simple like, oh, column 1 minus column 2, right? People want examples of things that are there, and the fact that there's no, you have to literally go find the formula, copy paste it in, and then use it. That to me, that's a miss.
Yeah,
I think it should be more open ended to the community to figure out. Okay, here's, for example, Marco Roots was going to put out, I don't know, 30, 40, I don't know how many. He's going to have examples of how to use these things all over the place. So I should be able to pick from his examples and then easily load them into my visual. That's what I want, because this is what I find a lot with Microsoft's new products or new features. I don't understand how to use it, so I have to spend time learning it. So I need to accelerate my learning path to get to use the feature, and then I can understand, okay, this makes sense.
Yeah.
Awesome. With that, let's jump into our main topic for today then. So the main topic today is from Sam. I'm going to maybe not do the last name the best. DeBrun?
Yeah, there you go. That's how it.
Hey.
Okay. From
Whether
Sam.
that's right
and,
or
so,
not, I don't know.
and we're talking this is from Sam's blog. It was published in 2023. Fabric Lakehouse or data warehouses. So I think it was October 19th last year when the article came out. But then talking through a bit more, what's the difference here? So Tommy, maybe give us a little brief summary of the article and give us a kind of a overview of where you want us to kind of start talking about things here.
No, Sam's been doing an awesome job. His blog has had great Fabric things, especially when it comes to the data engineering, understanding the Lakehouse. So he's been on a little series just about what the difference is between the data warehouse and the Fabric Lakehouse. So this article is all about, well, which one do you choose? Should you choose in between one or the other? And when do they make either sense together or sense apart? There's some actually really intriguing things that he was talking about what a Lakehouse is in terms of what we're kind of, I think, the conception of maybe it's a blob, but it's the back end of it, the engine that runs a Fabric Lakehouse, what we can do with it. So I think personally for me, I'm looking at this and man, this is still very open-ended on business teams and the self-service side, but we'll get into that. But honestly, just to kind of give that summary article, which one should you choose? Use cases for using both. Really, what is the difference from the engine point of view?
Let's go ahead, Seth.
Well, I think before we dive into like what's the difference in Fabric, like let's talk about what is
that's what I was going to go to
in the individual tools out there pre-Fabric, right? Where a lot of that, well, the vast majority of the major differences revolve around the back-end systems, where you have Lakehouse, which is predominantly, driven, I think, by Spark engines, right? Where you have distributed compute on and over the top of Delta Lake tables, or which is what I'm familiar. Databricks we've been doing this for 4 or 5 years. Distributed compute over unstructured Parquet files that have structure because of the Delta Parquet format. Your interface with a lot of this data, typically you're in this route because you're consuming a lot of unstructured data that you need to transform in that platform, and it's easier to do that with a kind of the distributed notebook system such that it is presented, and writing into Delta tables, reading from those in multiple different various languages. and this is a really high level and butchered way to describe these things, but the SQL DW is flattened data. It's completely different storage from the standpoint that predominantly most all of the interactions that you or I have are Azure SQL based, right? So you're in memory. You do not have the same type of distributed systems the way like Spark clusters work. And it doesn't handle the unstructured processing of data in the same way. So it's fantastic and always has been for very well-formed, very structured data to move from a structured place to another structured place for consumption. So it's all about, I think, the differentiation between those systems and when they are best used. There are always ways you can stretch the bounds of SQL DWs. They can go extremely large, but they still can't go as large as what you can in the big data unstructured ecosystems of Spark.
So maybe I want to pick on your comment there, not in a bad way, Seth, but I just want to maybe like understand a bit more where you're going with some of these things, right? You're talking like traditional versions of SQL, correct?
Mm-hmm.
Okay. So the reason I'm making that statement there is because I believe Microsoft went through a period of time where they've tried to change how people view SQL, and they went through this evolution of the MPP architecture for SQL. So SQL turned into SQL data warehouses, which was this massive was it massive parallel processing?
Yep.
MPP. So massive parallel processing. So now you get all these different SQL engines. Basically, it's like a chain of SQL servers that act more like Spark, where I have a lot of executors that can go run queries. And I guess also my mindset originally with SQL would be is SQL has its own had a contained compute and storage engine kind of all combined together, right? So it's like the thing that was all bolted together.
And there are still different flavors of Azure SQL, right?
Sure. Yes. So I think this is where the distinction is different now, because when Microsoft made Synapse, they were still using the MPP architecture in SQL, but inside Synapse, they started doing this. Okay, well, SQL Data Warehouse is too expensive to run. So what we'll do is we'll figure out a different way of charging you or billing you for how many files you touch. And this is actually a very Google type approach. So in Google, when you use like Google Cloud to write SQL against things, you can write a SQL statement. It hits files and it counts. Okay, how many files am I going to hit? And what's the size of those files? And then it charges you on the read of the number of gigabytes per query. So every query costs you something, but they just basically own the architecture of the infrastructure and say, look, I'm going to own this and I'll return you results for a certain amount of dollars, right? So you get like, I don't know what it was. It's, you get like a terabyte for free, and then anything above that you get charged, $1 per terabyte or something silly like that. I don't know what it is.
Right.
But the idea is like now the Microsoft had the same thing. I think it was like $5 per terabyte read of information. So it would read the files, it would track how much data was being read based on your queries, and then from that it would then charge you out how many terabytes of read data that was. So to me, that was like a good stepping stone. So that way it's kind of always on. It's this more SQL serverless experience. I don't want to pay for the server. And to me, the big my mindset shift here is there was a payment strategy kind of change in these new SQL serverless type engines. And then under the hood, Delta or Spark itself isn't the technology that's super slick here. I think it's the Delta table, honestly. It's Parquet.
Tables. Yeah.
Right. So when we're talking about like storing or compressing lots of data, I think the challenge, or at least what I've observed, is in order to get fast performance, you want to be able to store a lot of data in compressed formats and query data while it's compressed. Right. So if I need to read 300 gigabytes of data versus 50 gigabytes of data, anytime you're reading the smaller amount of data, it'll be faster. Right. So to me, the big gap here, the big technology leap is, in SQL, it's traditionally thought of as a row level store. You're storing every row of data. Mm-hmm. And in Databricks or Spark, or more, let's be very specific here, the Delta format that Spark reads is in Parquet format, which is a columnar store. So to me, that's like the big aha moment for me was like, oh, it's not just SQL versus Spark, it's columnar store versus row store. And that was the big difference for me. So I think there's a lot of patterns that kind of evolved out of this row store. No, one note in this article that I take a slight issue with, so that we're talking about like what is the SQL data warehouse, right? The SQL data warehouse is now more of this SQL serverless thing. It can read the Lakehouse, and in the article it says, I think towards the bottom here it says, in the bottom here, the Python side. So the Lakehouse and Python, the Lakehouse and Python there is no statement to like insert, delete, or create table as when you're talking about the Lakehouses. I'm not sure I agree with his assumption there around the Lakehouse. I'm pretty sure you can, with a Spark engine or the SQL engine, you can read and write tables inside the Lakehouse.
So that's actually what he goes into right after. And Mike, I was going to bring that up too. He makes the argument that, hey, a warehouse in Fabric is actually a data lakehouse, kind of on the back end, because the T-SQL abilities, all the normal tools. And for the lakehouse, he makes an argument that to read only, you can't use the statements like SQL, like insert or delete, but that's where the Apache Spark engine comes in and pandas come in. But to use SQL to write, I think that's what he's referring to, at least in the Lakehouse.
There's no Fabric Spark SQL statements that let you insert or update tables. I'm pretty sure that that's available. Well,
you can't do it in SQL. Yeah, I'm sure you can insert or join.
Spark SQL, correct?
Yeah.
It's not Transact SQL, but it's a different engine.
It's kind of splitting hairs.
It's like, why would you? To me, the comment feels misleading, is what I would say. It feels misleading. You're like, well, if we're only talking Transact SQL, yes, it doesn't have the exact same language as Transact SQL, but it has Spark SQL, which does these things that he's asking about: insert, delete, or updates. So to me, it's a moot point. It's like I don't even understand why that statement lives there, because you can still do those things inside Spark SQL. So I don't agree with that comment. So anyways, beside that point, right? Other than that, they're basically the same engines. They're basically able to do the same things, right? They're both able to query the data, read it out, and they're able to insert, update, or write data back to the Lakehouse using that same Delta format.
So here's something interesting. If you want to go into the weeds, there's a PDF that's actually the engine. Like, is Fabric Lakehouses in the backend just Synapse? And it's really not, apparently Microsoft's been working with Polaris.
They pulled all of Fabric is so. I've said this one before, and I'm pretty sure. This is how I look at it. I think of Fabric has now the best parts of Synapse reworked, retooled a little bit, made a bit easier because they've kind of redone the UI on some things. But when you saw original or initial things of it, it was like Power BI Synapse data engineering. It was Synapse something. So they even changed their labeling of things when they started out doing things with Fabric. So now that they've gotten rid of the Synapse portion or the labeling of it, they've just dropped all the language of Synapse pieces. And so now this is just Synapse merging into Power BI and now called it Fabric. In addition to a lot of other new things that they've added too, right? So it's not just the Synapse engines that they're pulling forward. So I would agree with you, Tommy. Like, I think, yes, this is just Synapse moved into Power BI now.
So as we dive into them, Sam goes into his recommendations, the Medallion approach, utilizing Lakehouses, warehouses. One thing that I'm really thinking about is call them the normal user, is the Medallion architecture, because it would be so, in a sense, easy to do in Fabric for those advanced users? Or is this would you consider utilizing this Medallion architecture, utilizing the Lakehouse and the data warehouse for self-service, just like we're doing managed self-service now? Do you see any potential there? Because that, I think, as we see all these, it's all in Fabric, this is great. Again, the Delta Lake, all the things that you talked about, for a lot of people, Mike, like that probably goes over their head if they've just been in Power BI or they're coming from the Power Platform. Obviously, our data engineers, we welcome you. But for a lot of people in the Power BI world, is that going to be something that I think is an expectation.
I think what you ask is a good question. So let me give you some context on where I think this is. I think it's a relevant question. I think there are some nuances to what you're asking about, right? So one thing I think I have to be mindful of here is if I say, hey, I'm coming at Fabric as the lens of a SQL developer. When I come at Fabric from a lens of a SQL developer, I think about staging tables and then final tables. I'm going to bring the data in, I'm going to stage it, prepare what I want to prepare, get it right, and then put it into my final table. So I think a SQL developer would think that way. And Seth, you can kind of confirm, right? From the SQL engineer, I would show up, make those tables, and then produce the final tables that I would, do my data in. Then if you come at this from a business user standpoint, they have no context of staging and final tables. They have no concept of bronze, silver, and gold. So that the business user doesn't really have that concept. Now, if you bring in a data engineer who comes from Spark, they would have the context of bronze, silver, gold, because that is more of a Spark big data type comment. And to me, the reason why you do SQL staging and final tables is because you want to blow away the data in the staging tables. You're not looking to keep all the individual records, because in the SQL server, when I had storage and compute inside the SQL engine, it was very expensive for me to have all the data every time I'm loading it into my main table. So that's because the storage was expensive relative to the compute that I bought on-prem, right? So I didn't want to buy a 100 terabyte SQL server because that means I had to buy really big machines to be able to store all the data. So it wasn't an efficient store of information. I couldn't store the data very easily. And because of that, volume of data became a problem. That's why we try to get rid of everything we wanted to lose. And I think that's also where change data capture came from. So CDC came from that SQL mentality of, okay, instead of storing every single record every time I load it, let's just compare my existing record to the new data that's showing up every day and only take the changes. So that's where the whole change data capture design, I think, flowed from, right? It's an efficient way of storing every changed moment of when a record is adjusted.
It isn't though. It's creating efficiencies between your staging and production tables. If I don't have to process an entire day and I only have to process the changes, that's gonna reduce the time of updating any facts or dimensions down the stream. It's not necessarily I don't have that data in staging tables. Like how are you building your ETL? Like how do you repair something if it breaks? If you don't have multiple different, like if you're talking about your raw and silver, right? Yep. Your first two stages in there. One is your historical record of everything from a raw ingestion standpoint. You're not breaking everything down, especially when we're talking unstructured data. Like you're not completely.
You're talking data engineering from a Spark developer standpoint. Is what you're speaking to right now. I'm talking from a SQL developer standpoint initially, right? So in the SQL developer, they wouldn't store every record on every day for historical purposes, would they?
Where else would you have your historical record?
Wouldn't they just kick that out somewhere else and store it in a separate database?
God, it's been so long since I've been
but to your point though, like the architecture is changing, right? So you went to the right place, I think, right? It's so we think of bronze. So all this to say, let me bring my point back here to like wrap it up.
So I agree with you from some point. At some point in time, you would not be able to store all of your data.
Correct.
In all of those things, correct, because you have to be cognizant of how much space you have.
And so my point is, like, you're building processes to say, look, here's the production server. I'm going to capture what records were added, which ones were deleted, and then I'm going to look for that information, and then I will make a reporting system that is only tracking the changes of those records, which is an efficient store of records when you have a limited amount of space to do these things in.
And a final point where they struggled, and still was unstructured or semi-structured data.
Yes, like I have a complex JSON object inside a column of a cell. How do I get that out? Like that's not an easy way to handle that inside SQL.
And what's interesting is if you look at the evolution of development and storage, like developers were all over unstructured data because they found that they could build
JSON objects
systems that were extremely fast without the need of SQL servers.
tables.
right?
Yes.
So
Right.
so while you obviously can't get away from that in certain scenarios where pure hardcore, like, you need accurate data all the way down to, like, there are no mistakes.
Mhm.
Like SQL, those systems are better than anything else out there, right? Even in terms of, there's too much that can be done in an unstructured realm that for high, what's the word, high security, high, accounting level things, tables and SQL is still where you want to be.
I mean, that's probably why you see most of the banking industry jumped on tables and have all their that's financials.
So
You
anyway,
can't be losing money anywhere.
Files,
but those are production systems, right? We're
Yes,
in the
correct.
realm of, hey, we can go, but
I mean, to your point though, Seth, like I think you're hitting a note here that really works well. Like when you had, like when the whole world ran on like back end systems, back end servers, SQL engine structured tables, right? That was, yes, that makes sense. But all of a sudden you get this thing called an API showing up, and everything is API based, and we want the websites to perform faster. And so the API says, look, I don't need a table anymore. Actually, what I want is a JSON object. And so that's where we start getting a really heavy, like where I see most of the unstructured data showing up, it's coming out of APIs. It's API based data, unstructured, semi-structured information. Yeah.
The ability to index them and quickly find the file that you need and make an update.
Yep. And this is where I think technologies like MongoDB, Cosmos database, like these are tools that are using that, a store of files, and I can query across them and return results from those files. So now the whole databasing architecture can go to a higher volume of files, but they can do it at a much cheaper rate to act like it takes less compute to get the data out. Right. And I think that shift has changed a lot of how we build things, and also the concept of APIs. So let me finish my point around the whole SQL Lakehouse, Tommy. Hold on your point, Tommy. Write it down so you don't forget it. So because I'll let you jump in here. All right, my whole premise here around SQL or Lakehouse was we need to educate new users to this concept of what is a medallion architecture. Now, people will have a lot of opinions on what it should and should not be. Ultimately, what I think it is your raw or your bronze layer is where you land the initial files and you just try and get something you can read and look at. The silver layer, however many layers of silver that you need, people think it's like, oh, it's just one table. No, it could be many tables that stack together to build anything in silver. But silver to me is like the cleaning, the transforming. Some people call it transformed, right? Some people will say raw, transformed, and then curated, right? So those could be the same levels of data what you're trying to do. But what you're doing is you're not copying the data. Instead, you're enriching the data. You're providing a pattern to that data. Maybe you're doing change data capture. Maybe you're doing remove duplicates. Maybe you're cleaning some records but that's silver. And the reason I think that's so important is because the silver area is, if we're talking that is the cleaning area, when I have problems with bad data, or I find that some bad data got through to my Power BI reports, where should I be looking to solve that problem? I should be looking at the quote unquote silver tables where I'm doing the transform. So one thing about this whole medallion architecture is it requires you to have designed areas to do certain activities. That way, when something breaks, you know where to look. So to me, it's like that's really important. And then finally, the gold layer is, okay, now I'm joining multiple tables together. I'm doing a lot more of facts and dimensions, and I'm basically building the data in a way that would say, I'm happy with how this data is transformed. I'm ready to share this externally with other users. Yeah. And we can then show a path of, here's how I brought in the raw data, here's how I transformed it in silver, and here's the final output of data to gold. Sorry, that's all I wanted to kind of bring out. But to me, this is like, I wanted to point out that this is a new thing that data engineers from Spark are trying to do, but the business user has no clue of any of this. And so we just have to teach them this is the better way to do, and this is how it should work in this new Fabric ecosystem.
So I want to play the other side as I think about this. Not that, and a caveat here, I am not arguing against the medallion architecture that has been tried and tested for large data, for in the ingestion. We know this. However, take the last 8 years of Power BI development. Power Query, maybe data flows,
sure,
maybe some tables, the clean digest, and obviously within just focus on the semantic model. So we'll say these people that we're talking about, or that kind of 80% of that audience that is that type of user, great in Power BI, great in DAX, really understands model development, Kimball method, all the things. They're great. So now we're just adding to their normal workflow that they have already been rapid development and managed their gold models, more tools and more steps and more languages that the organization is probably just not going to start hiring people who are well experienced in pipelines or in Synapse, that background. They're going to go, great, we want Fabric, cool. And then I think the biggest question I really do have is not so much the user struggling, but how much do you add to a process that potentially was, I don't want to say it wasn't broken, but there are use cases where I can see, I'm like, man, if I had this when I was here, this would have been great. Right. But I also have to have that assumption that I know the APIs, if there's no one else there to do that. I have to know that either notebooks, I could do Power Query in Fabric, but there's a big cost where I wasn't spending that before. So I think with the Medallion architecture, I would make more of an argument that for a good portion of users or scenarios that I think we're all assuming is lower right now, the data warehouse itself, creating that and just being able to push and store that data could be a little more useful, right? Because we're not introducing pipelines and files where maybe there were files, but the focus is just getting into a table and making sure that data doesn't change. And we know we can do the appending. These are a lot of concepts again. So then we at least kind of just take one step back in our source of truth, so to speak, from the table and what they can control. If we're adding all of this for not for every report, we're not going to migrate every semantic model to Medallion architecture, but I'm fearing, and I think the argument I'm making is the other side is everything you said is the right way to go, how data works in general. Stop. However, for so many things that Power BI analysts are doing, centralized BI teams, or more importantly, managed self-service, what are you expecting them to do?
Well, I don't understand why we're talking about that audience.
Well, so
let me jump in here before you. Let me see if I can clarify what you're saying here, Tommy. Let me hear what you're saying, and then you can tell me how off base I am on this one. You're asking about, I have workloads that exist in Power BI already today. I'm already loading data in using nothing but import. I'm figuring it out. I've got things coming in. What is the path to migrate those users into a Medallion type architecture? And do they need to always be using Fabric and things that are Fabric-esque, such as bronze, silver, gold, and loading data that way? Mm-hmm. So is that what you're asking?
That's 1,000%.
Okay. 1,000%. So I guess the answer. So let me give you my answer, and then I'll let Seth. You can kind of chew on your answer a little bit here too. So, what is the migration path for existing Power BI users? Just because Fabric showed up doesn't mean you need to stop everything you're doing and move over from what you were doing previously in Power BI. You can still leave those the way they are. Where I think this becomes more impactful is if you're an organization who already has designed cloud-based data system practices. You're coming out of Snowflake. You've already got Databricks. You already have things that are already in the cloud. You understand the cost of those things, and you've already justified the value for those costs. There's no need for you to change. You don't have to change anything you're doing. You leave it alone, right? You just keep doing what you're doing, and you just use PowerBI.com for semantic models, importing data, and using reports. I don't think you need to change that. However, if you're a company who's adding a new data source, if you're a company who's now trying to integrate with cloud-based things for the first time, you're now purchasing Salesforce or NetSuite or something else that's in the cloud, a service, and you don't have a cloud presence today currently, then I think you're more apt to do Fabric. And I talked to a lot of other MVPs around this, and they said most companies who are starting to use Fabric are companies who never had cloud before and are now starting to dabble in it for the first time by obsolescing some of their homegrown internal systems in favor of, I'm now building or buying software that is cloud-based and I need to get the data out. So to me, that is the decision point for when should I really seriously consider using Fabric. And there may be some existing companies that do have cloud data and they want to migrate off of their old systems, but it only makes sense when it costs me less than what I'm doing right now. And so I'm not sure there's a compelling story yet for if I own Databricks and I'm already doing all my data engineering somewhere else, I don't think it makes sense yet from a pricing standpoint to fully move over all of my existing workloads 100% into Fabric and migrate them. I think there's a certain level of this. You have to kind of evaluate what makes sense and what doesn't. And again, to be very clear, stuff you've been doing for the last 7-8 years in Power BI, they just may need to live on, right? That's okay. You can just let those things live on. Not an issue. And then when you need a major upgrade, that might be the time to say, okay, do we need to take a relook at this? Is there a faster, better, more cheaper way to do this? And one of the points that's not made in this article that Sam wrote was you also have to evaluate how many compute units does it take you to do the same workload. Now, I don't know if that's different or not, but I would argue potentially here there's going to be a different. So if you think about how these different engines are talking to the Lakehouse, the SQL engine versus the Python engine, they're using different languages. One might be using Java, one might be using C#, one might be there's engines that have different languages that access the lake. Inherently each of those languages will have a different speed performance. So it's like you do any kind of speed test. There's certain languages of code that run faster than others to do certain jobs. It's the same job, but they run differently. You have to go in and, when experts go in and have to do large data sets, accessing lots of data, verify that those workloads cost you a certain amount of stuff. What is the number of CUs for those activities? And I think that will help you decide which one of these are better. I would liken to argue, and again, I don't have any data to back this up. This is just my pure speculation, right? I would liken to argue right now, if you had a very large, New York taxi level data type stuff, and you start ripping around on top of the SQL data warehouse on top of that, and you compared the same queries or getting the same data out using the Spark engine, I would think the Spark engine will cost you less CUs than the SQL engine. Because I believe there's less overhead in Spark to go get the data versus the SQL endpoint. Now, I don't know if that's true or not. So anyone, Mim, if you're listening, I'd love you to go do something like that, Mim. Show us. Maybe you've done it already. I haven't seen it, but send me the link in the chat or put it on the video, Mim, if you hear this at all. But I'd like to see some comparisons of here's the same workload done two different ways, and then a SQL engine cost you 1,000 CUs. The Spark engine cost you 950. Right? Whatever that is, right? To me, there's something there that would push you one way or the other. And as that data volume size grows, maybe there's a widening gap between what SQL can do and what Python can do or Spark can do. And I think that would be maybe your decision point later on, but that's like super tech. That's for a data engineer, right? In most cases, I think business users are not dealing with hyper volumes of data, like to the tune of billions of rows of data. Business users are dealing with like thousands of rows of data, right? Hundreds of thousands of rows, millions of rows of data, right? That's a space where I think they would be very comfortable. And at that point, the deviation between the two different engines may not be enough to even make a difference. It's like meaningless, right? It's not even worth the time. Just use what works best for you.
Right.
So you're asking a very simple question, Tommy, and I'm really like diving into the thought, and that's how my brain works when I'm thinking through like, what engine do I care about?
Okay, so from the I'm just going to recap into this one.
Sorry, I said a lot of things. Yeah,
because
please do.
Well, it's the time you're bringing up the business user, like the user, the analyst who's already doing the stuff. And I guess the summary fits in here before I answer. When comparing Lakehouse versus Data Warehouse and the ways we've described the two systems and then how they're going to work in Fabric, like ultimately the Lakehouse offers much cheaper storage without capacity limits, adds a lot of the data warehouse typed features, but also incorporates a lot of the flexibility that was not there in warehouses, and obviously like areas of like trying to drive for cost efficiency. I think Fabric is bringing all of the Microsoft services together. the key linchpin that we've talked about is all of those services are now over Delta tables, right? So you're introducing that cheap layer of storage or the structure of those tables on cheap storage of Azure Data Lake storage so that you can work with unstructured data. You have access to EasyML. You have all the engineering things. You have the cheap storage. You have flexibility of languages. All of that is for like the hardcore DE, better systems all in the same place to create the gold standard, right? All of those things are the enterprise systems that you would need to do that. But for business users, you still get Delta tables, regardless of Medallion architecture, because that's not part of the conversation, even though they're doing it. They're still doing ETL, right? They're still connecting to sources. They're just building everything in that report layer. And I think that falls into the conversation of, hey, when that gets to a point where that's being widely shared throughout an organization or has a ton of value, business intelligence teams take a very interesting, like a lot of interest in what's going on there, right? Especially if it's not performant as well. So there is no change for them. They don't have to learn all of these other things. They're being like, in this way, I don't, while I would agree with you in many cases of like, wow, we're really like throwing a lot of information at these users, I don't think this is one of those because it's just one like Delta tables for all of the stuff. So you still get the scale, which they didn't have before. You still have cheap storage, and they already have their gold because that's what they're building. Like ultimately, their little microcosm of connect, transform, and now I have my model is the same thing that's being done on but albeit slower and with more data in these other bronze or silver layers as part of the other aspects of Fabric and other users that are going to be doing those engines. That's my perspective.
I think it's a good one. I like that one a lot. I mean, I think it does a good job summarizing.
I mean, if you don't agree, you ask the question.
No, I do agree. I mean,
I'm talking to Tommy.
Oh, go ahead.
He's
Sorry.
making faces, and he's just like,
I just honestly, it's just talking to people who are also nerds. It's just so nice. I don't know who else is talking about this at 7:30 in the morning.
No one, because everyone else is sleeping at this point. So, any reactions, Tommy? Before you want to give like some final thoughts on this one?
Honestly, I'm really looking forward where this is going. I love the articles. Make sure to check out Sam's article, and also there's a link to his previous post where he really dives into the Polaris engine, deep dives into really the back end, which is pretty interesting. So there's so much to learn. But no, you guys are. We'll talk about governance as we continue to go in the future. But
I will. So let me I'll give you my final thoughts here. So governance is another whole ball of wax that we should need to talk about too, because I think the engine choice also helps out with governance pieces as well. At the end of the day, right, it has to be a progression. I'm not sure the data engineer and the data scientist are running to Fabric saying this solves all my problems or does everything I needed to do. They already have tools today that they've been doing data engineering in that they're probably comfortable with today currently. However, for the crazy amount of business users that have been using Power BI, this gives a huge amount of opportunity on tools that are enterprise grade. So I really like this story, this article, when we talk about this is the grow up story. This is what we were asking for Power BI to do a while ago. Grow up, do something. Like you're going to use a Power Query to get data into something. Let me store it. Let me hit it with anything you want. And again, I'll keep leaning on this one. The magic, the secret sauce here that we're talking about, it doesn't matter if it's Lakehouse. It doesn't matter if it's Spark, SQL, Kusto. I don't care what the compute engine is. All of them talk Delta and use the one lake. Yeah. To me, that's the really value add here. Again, it's the value add of it doesn't matter what engine you're using. Use whatever you're comfortable with, and Microsoft will make it optimized in a way that all can talk to each other using the Power BI side. One thing I do take issue with a little bit in this article here at the very end is inside this example at the very bottom. He said when to use what at the endpoint. And there's files, tables, and a SQL data warehouse. So bronze is files, silver is table-based formatting, and gold is a SQL data warehouse at the end. I think this is just one of many patterns you can use. So I think it did a little bit of a disservice by saying this is how I see it running. I think it's worthy to note that this is one way to think about how to do your data, because this doesn't account for Direct Lake, which I think is an incredible game changer. That means so Direct Lake allows the Vertipack engine to directly read the Lakehouse. To me, huge amount of improvement. And if I don't have to spend time every day computing a load on a table, I can shift my compute work that I would have done for loading for hours at a time. I can move that over to data engineering and shape my data upstream to get it ready for loading in a more efficient way. So I think this is a early look at what the potential architectures will be. And we need more examples and more time to really build out what we want. So good article. I think good thoughts. Use what engine makes sense best for you. And when you get to really big scale data, that's when you really need to evaluate what's the right engine to do the job. Because I think that's when you start talking large amounts of data, you now have to seriously think about the engine. Okay. With that, you've burned through a perfectly good hour of time thinking through and talking through all the things here. We appreciate your time. Thank you so much for listening to the podcast. Our only ask is if you share it with somebody else. With that, Tommy, where else can you find the podcast?
You can find us on Apple, Spotify, wherever you get your podcasts. Make sure to subscribe and leave a rating. It helps us out a ton. If you have a question, an idea, or a topic that you want us to talk about in a future episode, head over to powerbi.tips/podcast. Leave your name and a great question. Finally, join us live every Tuesday and Thursday, 7:30 a.m. Central, and join the conversation on all Power BI tips.
Excellent.
Social media channels.
All right. Thank you all, and we'll see you next time.